Welcome to today's Explainer, where we're taking a really hard look at a foundational rule of physics, the information loss law. We're going to dive into a totally fascinating framework that, well, attempts to completely flip this rule on its head. So let's stretch our minds a bit and rethink the absolute building blocks of reality.
Let's start right out of the gate with a massive cosmic mystery. It's one of those questions that's literally kept physicists up at night for decades. Is information ever truly lost? Think about it. When you look up at the universe, or, consider the mind-bending extreme environment of a black hole, what actually happens to the underlying data of reality? Does it just vanish into nothingness, or does it somehow stick around forever?
Now, the generally accepted answer is framed by something called the information loss law. Basically, this is the widely held scientific premise stating there can be absolutely no information loss in the universe, or even within a black hole. In mainstream science, this is kind of treated as a solved case, right? An unquestionable pillar of how reality works. But as we know, to truly understand the universe, we've got to critically examine our deepest assumptions.
Which brings us to Section 1, the problem of distinctions and its core dependencies.
See, to rely on this law of information conservation, we really have to understand what it depends on. We need to step back and ask, okay, what does information actually need to exist in the first place? Well, this logical chain lays it out perfectly. Step 1, we first have to make distinctions between objects. We have to be able to say, hey, this is object A, and that right there is object B. Step 2, once we've got those distinct objects, we can then describe the entire system using information. And finally, step 3, according to the standard rules of physics, the information about that system and its entropy can only increase or stay the exact same. So making distinctions is the absolute prerequisite here. It's the mandatory starting line. Without the ability to divide the universe into separate parts, the whole concept of information just completely breaks down.
So here's the really crucial point. For information to be the final word on reality, we absolutely have to get those distinctions right at the very lowest level. Now, at the macro level of our everyday lives, or really any other level, the information content is naturally smaller, so distinctions are pretty easy. A table is clearly distinct from a chair. But at the most elementary level, the level of the absolute tiniest details, that's where we must get the distinctions perfectly right. This means the whole idea of information heavily relies on distinct, separate objects actually existing at the very base of reality.
Moving on to Section 2, the lowest level. We're zooming all the way in. As we travel down to the sub-elementary level, the absolute rock bottom of existence, we kind of need to prepare ourselves for a major paradigm shift. Think about this for a second. What if, at this lowest, most detailed level, there is no such thing as a useful distinction? Try to mentally dismantle that assumption we all have that the universe is made of tiny, separate, distinct building blocks, like quarks or strings. What if those individual separate blocks simply do not exist down there?
And that leads us to this incredibly fascinating proposition from our source material. Quote, nature does not have or need any distinctions to change. Wow, it's a really powerful, radical challenge to standard physics. It's essentially suggesting that the very act of dividing the universe up into separate, distinct pieces, well, that might just be a limitation of our own human observation and not a true feature of nature itself.
All right, Section 3, the elastic universe. Let's look at a new framework.
So, if the universe isn't made of tiny, separate, distinct objects, then what on earth is it? Let's introduce a totally new framework, a new suspect in our cosmic mystery, if you will. Now, this concept isn't just some overnight thought experiment. It's been carefully developed over decades. Back in 2002, this alternative perspective was introduced in a book by S.J. van Stekelenburg. And as we trace this timeline from 2002 onwards, right up to 2025, we see the theory being continuously refined. Yet remarkably, nothing basic has changed in the meantime. The core argument has stood entirely firm over all these decades.
The foundational premise of Stekelenburg's work is honestly staggering. The idea is that reality is exactly this, one three-dimensional elastic object. This incredibly bold theory states that nature and the entire universe aren't made of countless separate parts just bumping into one another. Instead, they are in fact just one single continuous entity. There's no empty space filled with floating particles. There is literally only the object itself, comprising absolutely everything.
Let's break down exactly what this means, because it completely reshapes physics. We were talking about a single, continuous object. It is three-dimensional, and crucially, it's elastic in its nature. Because it's elastic, it is constantly changing its shape under immense tension. And this shape-shifting, all the bending, stretching, vibrating, and morphing of this one single object is exactly what we perceive as reality. So in this framework, what we traditionally measure as separate particles or matter are really just localized vibrations, knots, or tensions within this one singular elastic medium. It's sort of like an ocean with endless waves, but it's all just one continuous body of water. This model completely bypasses the need for making distinct boundaries at the lowest level. It swaps out the old system of a fragmented universe for this beautifully unified, dynamic whole.
So, I want to leave you today with the text's final, super provocative thought. Should we investigate it? I mean, if information loss laws depend entirely on making distinctions that might not even exist at the fundamental level, and if an elastic universe offers a completely unified, distinction-free model of reality, isn't it totally worth our time to look deeper? Keep questioning those foundational rules, keep exploring alternative models, and definitely never stop being curious about the absolute fabric of the universe we inhabit.